Hello dear students, welcome you all on my YouTube channel Tesla Tutorial. Dear students, in this video we are going to learn about some certain rules in case of image formation with the help of convex or concave mirror. These rules are completely based on the observations obtained from the experiment of the image formation by convex mirror or concave mirror. These rules are same in case of convex as well as concave mirror, but as concave mirror is converging in nature, it means it converges the rays of light falling on it, while convex mirror is diverging in nature. It means a convex mirror diverges the rays falling on it. That's why the ray diagram will be different in both cases. So we will study these rules separately for concave mirror and then for convex mirror. First, let's see for the concave mirror. Concave mirror. So for the concave mirror, here I am constructing a concave mirror. In the last video, I explained each and every details related to the convex and concave mirror. So suppose this is the midpoint of the mirror regarded as the pole. In case if this line is the principal axis, then suppose this point is the center of curvature and the distance between half of the distance between C and P means center of curvature and pole regarded as the focus. So the first rule for the ray diagram says that if any parallel rays of light falls upon the concave mirror, then these parallel rays after reflection from the mirror, concave mirror, passes through the focus of the mirror. Again I am repeating, now you can note it. If the parallel beam of light falls upon a concave mirror, then after reflection these rays passes through the focus of the concave mirror. The second rule, again we must have a concave mirror. Suppose this is pole. If this is the principal axis, then somewhere center of curvature and focus F. Just opposite to first rule. In first rule you said that parallel beam of light after reflection passes through F, but here you are going to say in case if ray of light is passing through the focus of the concave mirror and falling upon the mirror, then after reflection this ray become parallel to the principal axis, just opposite to the first rule. Again, ray of light passing through the focus and falling upon the concave mirror after reflection from the mirror become parallel to the principal axis. Now third rule, pole, center of curvature, focus. Third rule is that any ray of light passing through the center of curvature and falling upon the concave mirror after reflection retraces its path. Let's see why it happens. As you all know, this C is center of curvature is actually center of the sphere of which this mirror is a part. It means any line passing through C to mirror point can be considered as radius in case of that sphere as well as in case of this elementary part of that sphere. In this way, you all know that in case of sphere or in case of mirror, radius is always normal to each point of the circumference or each point of the surface of the sphere. So this is the radius as well, this is the radius, So in that case, any ray falling along the radius, that is falling along the normal. In case of a normal incidence, this is normal incidence, means in case of this, angle of incidence becomes 0. If you can remember, here this is a reflecting surface, suppose, and this is the normal, and you all know that angle of incidence and angle of reflection is taken from the normal. If any light is falling along the normal, then in case how much angle this incident ray is making with the normal, obviously you will say 0. So angle of incidence is 0. If angle of incidence is 0, then law of reflection says that angle of reflection also must be 0. That's why this ray retraces, means this ray which is passing through the center of curvature of the mirror retraces its path. Again, see one more thing. In case if you want to draw normal at any point, suppose here this point A is the point of incidence, you can consider this rule as fourth rule. Suppose here this point A is the point of incidence, and you want to get the angle of incidence as well as angle of reflection at A, then you must have normal at point A. In order to draw the normal at point A, simply you have to match point A with C, as I explained everything of this here in third rule. So I think this is clear to you all. Now let's see the same rule in case of convex mirror. In case of convex mirror, as if we are talking about convex mirror, then simply we polish the inner surface like this. So here, if this is the midpoint, then pole, suppose somewhere focus just twice to this center of curvature. Here this rule means if any ray of light falling on the mirror parallel to the principal axis, then after reflection it passes through the focus. You said here what you will say, any ray of light from this side, any ray of light falling to the convex mirror, after reflection they seems to coming out from the focus of the mirror. Again I'm repeating, parallel beam of light falling on a convex mirror, after reflection seems to coming out from the focus of the mirror. Actually these rays, if observer is here observer is there, here if he is looking these two rays, then actually these two rays actually looking to this ray, then actually this ray does not seems to coming out from this point actually, because observer always see the straight path of light. So the straight path of this light is this much, is this one. So to the observer it seems that the source of light is here at F, not here. Okay, the second rule in case of convex mirror, see, in second rule you considered just opposite to the first rule. Here if any ray, here you will say in the second rule you will say in case of convex mirror, you will say that if any ray falling on the mirror seems to pass through the focus of the mirror, means if you extend the path of this light, and you get that this light, if the mirror is if we are not considering the mirror, then this light must pass through F, then in that case after reflection from the mirror it becomes parallel to the principal axis, means ray of light falling upon the convex mirror and seeming pass through F, after reflection from the convex mirror become parallel to the principal axis. Now the third and last rule, as you said here in case of concave mirror, you said that ray passing through C after reflection retraces its path. Here you will see ray falling on the convex mirror seeming to pass through C. Means if you extend the path of the light, then you will get that this ray will pass through C. This is condition, virtual condition. Actually light is not going behind the mirror, but if you are not considering this reflecting surface, if light may transmit through this, then it must pass through the C. If this is the scenario, then in that case light retraces its path. Means if light falling on the convex mirror seems to pass through C, then after reflection this ray of light retraces its path. Again same thing, if you want to draw normal at any point, suppose here if you want to draw normal, then in that case you will sketch a line on this point in such a way that if you extend the path of that line, then it must pass through C. So for sketching normal, for drawing normal at any point, we have to match that point from the center of curvature of the concave mirror or from the convex mirror. So these are the basic rules to draw the ray diagram and to form image in case of concave mirror and convex mirror. You do the exercise on these rules, means revise these rules.